So in this second video in the organic chemistry series, guys, we're going to start looking at the homologous series. Now this is an entirely new term for you. It's one of your CA definitions, so please make sure to learn it. It's on the board now. So it's a family of organic compounds. So remember we talked earlier about the fact that organic chemistry dealt with carbon-based compounds. So within that you have a variety of family of organic compounds. They have, and this is their definition, the same general formula. And you probably remember in the last video I talked about alkanes having CnH2n plus 2. That was the general formula for alkanes. You might also remember I talked about, and very briefly I talked about alkenes, another homologous series having a general formula of CnH2n. Okay, these things are made by the same means, so you remember your alkanes are made by fractional distillation, and they have similar chemical properties, not the same but similar chemical properties, and a steady graduation in their physical properties. So you might remember, for example, when we talked about the alkanes that were made in the fractional distillation tower, they got less viscous as they had went from the bottom of the tower to the top of the tower. They had lower boiling points as they went from the bottom of the tower to the top of the tower. They got lighter in colour. So all those things represent a steady graduation in their physical properties, and they differ by a CH1 unit. If you maybe remember, if I can go back to it here, this was a table of our, going too far, yeah, this was a table of our alkanes here, and if we look at it, we go from there to there. Now I probably just we'll go from there to there, so it's plus CH2. Again, from the next one to the next one, it's plus CH2. Likewise there, plus CH2. Okay, plus CH2. So each time I go from one to the other in the family, in the homologous series, you can see that we're adding a CH2 to it. Okay. Now there are a huge number of these families of organic compounds, these homologous series. The ones that we will look at GCSE are alkanes, alkenes, alcohols, and carboxylic acids. Okay, so we're going to start looking at alkanes and alkenes first. They are the two that are actually hydrocarbons. Alright, so they contain only carbon and hydrogen. The others contain some oxygen, so they're not defined as hydrocarbons. So let's look at alkanes and the bonding in them first and foremost. Well, we know the electron configuration of carbon is 2,4. We know carbon has atomic number of 6, electron configuration of 2, 4. And that means that every carbon has to form 4 bonds. So alkanes are what we call saturated hydrocarbons. Okay, so they contain only carbon-carbon single bonds. Some others, and we'll look at them later, when we get to alkenes, contain carbons with double bonds. They're said to be unsaturated. But alkanes are saturated. They only contain carbon-carbon single bonds. And that means that every carbon in them has to be bonded to 1, 2, 3, 4 other things, 4 other atoms. Okay? Whereas in an alkene up here, for example, because it has a double bond here, that would only have to be attached to 1, 2, and then there, 3 other atoms. Okay? So these are the alkanes that you have to know. In fact, you don't have to know pentane. Okay? You need to know the name, the molecular formula, and to be able to draw the structural formula of it. I wouldn't worry too much about the ball and stick model, it's just there for your information. Now, how do we know how to name them? Well, remember, they are, as I said, alkanes. So when you look at the name at the end of all of them, you have ANE. And that tells me that they are alkanes. So this is like a code. Now, where does this first part of the name come from then? Meth, eth, prop, bute. Where does that come from? Well, that comes from the number of carbons. So here I have 1. The code in chemistry for 1 carbon in a molecule is meth. 2 carbons, the code is eth. 3 carbons, I'm sure you're getting the picture now, prop. And 4 carbons, obviously, bute. So we put those two pieces of information together. They're all single bonds. They contain carbon and hydrogen only. So therefore they're alkanes. So their ending is ANE. We then count the number of carbons. In this one we have 1 carbon and the code is meth. We put those two pieces of information together and we have methane. For example, down here. Okay, it's all single bonds and it's carbon and hydrogen only. The ending is Ne. I have 5 carbons in it here. So that is pent. Pent is 5 for 5. Okay, and those you have to know. The first 4 there, from methane down to butane, you have to know. You also have to know that they are all gases. Okay, that's quite easy to remember. Okay, now as the number of carbons in those gets greater, well, so does the melting and boiling points of them. And that's because the intermolecular forces, the ones that you would need to know about, are the van der Waals forces, get stronger. If you remember, in the fractionating column right down at the bottom, the bitumen was a solid, whereas and they were the very, very long molecules. Okay, so that bitumen has a carbon content of sort of over 70 carbons in it, whereas up at the top you had the gases, the very light gases, and they're very small molecules. Okay, so all of those things you should will work. Right, so those are the sort of the physical properties of the alkanes and the explanation for the physical properties and how to work out the formula of them. Right, and these alkanes also, they're very unreactive. Okay, the reason why they're very unreactive is because the bonds in them are extremely strong. Those carbon bonds and carbon hydrogen bonds are very strong, but they do burn, and we use them to burn all the time, as we've already spoken about in the previous video. And we get 2 types of combustion, which are you need to know about: complete and incomplete. So complete combustion of methane. Complete combustion is when you have lots and lots of oxygen, more oxygen than you need. And you always get in complete combustion carbon dioxide and water. Okay? And when we're doing these equations, this is a tip for these equations. Balance them, in alphabetical order. So for example, if I had, I'll take a slightly more complicated one here. If I had pentane plus oxygen, O2, remember it's always O2. Complete combustion always gives me carbon dioxide and water. I balance them in alphabetical order, so carbons first. Well, I have 5 carbons there. The only way I can get 5 carbons there is by doing that. I have 12 hydrogens there. The only way I can get 12 hydrogens is by doing that. Okay? And then if I add up over here, I've got 16 oxygens. Well, the only way I can get 16 oxygens is 8 O2s. Okay, so there's butane. Okay, so have a go at that. You should know butane. Now but was 4, so it's C4, CnH2n for alkanes, so C4H10. So have a go at writing and balancing the equation then for the combustion of butane. Pause the video and then I'll put the answer up. Okay, so that's what you should have got. Okay, so how do we test these products? You have to know how to prove that the products here are carbon dioxide and water. And this is very simple. You've done this already. Maybe have a think about it and pause the video and then come back and check the answer. So, well, we pass the gases through lime water, which turns milky. That tells me I've got carbon dioxide. Okay. The other thing I can do is cool the gases down and I get a colourless liquid. That should be water. And then I can add that liquid to anhydrous copper sulfate, okay, which should turn from white to blue if it is in fact water. So those are 2 tests for the products of complete combustion that you have to know. Let's look at incomplete combustion. This happens when we have a limited amount of oxygen. Okay, so not enough oxygen around. And this time we get carbon monoxide, and you might get some pure unburnt sooty carbon as well. Sometimes if there's a real lack of oxygen. You also get the water. You still get water as we got in complete combustion, okay, but you get less carbon dioxide. So if you look at this, we've got methane this time and we've got carbon monoxide this time in the water, so no carbon dioxide. Okay, there's butane. Okay, so same thing. All right, and hexane. Okay, so there's three equations for to illustrate, the incomplete combustion of particular fuels. Okay, now if we just have a look in our notes, excuse me, in our notes, guys. If you go to there's some task here, page 7, okay, and page 8 of your notes, which ask you to write some equations on complete and incomplete combustion. Okay, there's then some tasks on page 9 and 10 which you can do the reading for and have a go at those. Those should be fairly straightforward for you. Okay. So you probably want to pause the video, guys, and then have a go at those tasks. Right. So problems with combustion. Okay. You hopefully have read by now that carbon dioxide gives you global warming. Okay. Carbon monoxide is highly toxic. All right. Black soot, people can breathe it in. It coats buildings. Okay. So there's a few that you need to be aware of. How do we reduce these fossil fuels? Well, you burn less fossil fuels to reduce the pollution, yeah? You use more renewable fuels, of course. You use low sulfur fuels. Okay, they can be a bit expensive, that's the problem with them. You can sure use electricity efficiently. Switch off all of your switches, your lights, etc. before you go to bed at night. Use catalytic converters in cars. They're now pretty much standard in all cars. Okay? So you've got to be able to briefly explain why is it that carbon dioxide can indeed cause this global warming. Okay, and that's talked about on page 8 of your notes anyway, so you should be able to do that reading. Right. Well, basically, because it's building up, this carbon dioxide is building up in the atmosphere, okay, and it's a really good at grabbing any heat energy. So if that is the Earth there, right? Okay, and this is the atmosphere around it, and that atmosphere is having increasing amounts of carbon dioxide. And there's my sun, right? Okay, excuse my artwork. So energy comes in from the sun and it bounces off. It bounces off the Earth. Some of it's absorbed by plants and buildings, etc. But some of it bounces off, and generally a lot of that would just go back out into space again. But carbon dioxide is really good at stopping it doing that. Carbon dioxide traps it in our atmosphere. And if you trap heat energy in the atmosphere, like trapping heat energy in a room, that will get warmer. It will cause it to get warmer. So it prevents the escape of a certain amount of energy from the Earth, and that causes the Earth to get a little bit warmer. Primarily the energy that carbon dioxide traps is infrared radiation, infrared energy. Okay? And the negative impacts of that will be, well, you're going to get an increase in global temperature, melting of polar ice caps, sea levels will rise, you probably get flooding of coastal systems, loss of habitats in those particular areas. Okay, carbon monoxide then. What's the problem with it? Well, we've already discussed it's a colourless, odourless gas, but it's toxic because instead of allowing oxygen to attach to your red blood cells, okay, what it does is it attaches to the red blood cell itself, and the oxygen can't get on. And if you can't get oxygen around your body, your brain will switch off, and if your brain switches off, unfortunately all of your body switches off. So you need to be able to be aware, or be able to briefly explain how do you prevent such things happening in the home. So it's about getting boilers serviced regularly. Okay, and that makes sure that there's no blockages in them, there's plenty of oxygen getting to them, and therefore there is no build-up of carbon monoxide in your home. Sulfur dioxide we've already spoken about. Okay, comes from impurities in the fuel. Alright, and when it's burnt in the combustion process, it gives you sulfur dioxide, which then reacts with rainwater to give us sulfuric acid, and then when the rainwater falls, it comes back to Earth, causes problems. And the problem with sulfur dioxide is because it's a gas, it has no respect for borders, it just travels wherever the wind takes it. So we could make sulfur dioxide in our country, and that can cause big environmental problems in a variety of other countries which perhaps themselves don't produce any sulfur dioxide pollution. So So there's a moral duty upon countries who do produce it to solve the problem. Okay, so that, guys, is the second of this, and that should take us up really to the end of page 11, or page 11 in our notes. So you should have all of your gaps, sorry, page 11, you should have all of the gaps and all of the reading done up to sort of halfway down page 11 there, where you'll see the subheading alkenes, which is what we will pick up on next day here. Okay, our next lesson, I should say. Okay, so we'll pick up on alkenes then. Alright, so that's our alkanes, our combustion or incomplete combustion, all done, guys. We'll pick up from there next time.